This is our third and final video for the final exam review. So this first one here, it says if P dollars is deposited in a savings account that pays an interest rate of R% per year compounded continuously, find the balance after T years. So because it says that the interest is compounded continuously, this is the formula that we use. There is a different formula if it had said compounded quarterly, monthly, semi-annually, but it didn't. It said continuously. So here's our formula. A is what we don't know. That's what we're supposed to be finding, is the amount after T years, or the balance after T years. The principal was given to us, it's 1,000. The interest rate is 2.9, but when I put that in the formula, I do have to enter it as a decimal. And to convert from a percent to a decimal, we move the decimal point 2 places to the left. Okay, so that's why I'm entering 0.029. And then finally, we multiply that times T, which is 3. To compute this, I'm going to use my calculator. I have a graphing calculator, which we do not want you to use, but I promise I won't use any function that your scientific calculator would not have. So everything I'm going to do, your scientific calculator would be able to do as well. So I'm going to type in 1,000. And then get my E. For this calculator, I have this LN button. And if I hit my yellow second button and then hit that button, it'll raise E to a power. Inside there, I'm going to take 0.029 and multiply times 3. Close my parentheses there, and it looks like I would have $1,090 and 90 cents. What follows the decimal is a 0.89, but if you look beyond the 9, we have a 6, which would tell you to round up, and I can't round a 9 to a 10, so we make that 90 cents instead. So it looks like 1090.90 would be the amount. It is going to tell you to round your answer to the nearest cent, which means 2 decimal places. So the next one, it looks pretty close to what we just did, except you may notice that instead of giving us the principal, P, we're given A. It's still compounded continuously, so we're still going to use this formula. But instead of solving for A, we're solving for P. How much money will amount to $8 after T years? So 15,000 is what we want to end with. What we need to invest today, we're not sure. And interest rate is 4.2, but that's as a percentage. And so I want to enter it in as 0.042. And then T is 10. To solve this, we're going to need to divide to isolate the P. So I'm going to divide both sides by E to the, let me go ahead, if you take 10 times this, we're just going to get 0.42. So this, if you actually find that, it's just 0.42. So it's E to the 0.42. So I'm going to divide both sides by E to the 0.42. So my principal, which is going to be less than 15,000, because remember, this is what we're going to invest in order to end with 15,000. So this time I'm going to enter 15,000, but I'm going to divide by E to the 0.42 instead of multiplying. So looks like we need to invest $9,855.70. Now this is what WebAssign will want for a problem like this. I did want to mention that technically a better answer would actually be 71 cents instead of 70 cents, because if you look, even though what follows the 0 is a 2, which would tell us not to round up, if you only invest $9,855.70, you won't quite have $15,000 after 10 years. You would actually want to round that up no matter what. That's only when you're trying to solve for the principal P. So, but again, this is what WebAssign would want this. So don't worry about what I just said. Okay. Our next problem, 19. Sorry, I'm going to erase all this. So for 19, we want to solve this logarithmic equation. And we're going to have to use our properties of logs. Our properties of logs say that a sum of logs with the same base can be written as a single log as long as we multiply those arguments together. Okay, I know it seems kind of weird, but we do multiply those arguments together. So we have log base 2 of x squared plus x minus 12 is equal to 3. So when I multiplied those, I FOILed, and I combined my middle terms as I FOILed. So we had a positive 4x and a negative 3x. So that's where I got the 1x in the middle. So now to solve this, I'm going to use the definition of a log. It says that that argument, x squared plus x minus 12, is equal to 2 to the third power. So I'm converting into exponential form. And to do that, this is my base. And this is my exponent. And we set that base to this exponent equal to the argument. 2 to the third power is 8. And in order to solve this quadratic equation, I'm going to need a 0 on one side. So let me subtract over the 8. So we have x squared plus x minus 20 equals 0. So we're going to get two potential solutions since I have a quadratic equation. To factor that, and it does factor, so let's go ahead and factor. We're looking for two numbers. We want them to add to positive 1, so add to 1 and multiply to negative 20. Those two numbers are 5 and negative 4. And then when we set those factors equal to 0, we get x equals negative 5 or 4. Now, the only solution is 4. Negative 5 is extraneous. Let me show you why. Remember that the log of a negative number, or even the log of 0, that's undefined. So if I want to plug negative 5 back into the original equation, let's see, that first term is log base 2 of x minus 3. So if I go to test x equals negative 5, log base 2 of x minus 3 okay, plus dot, 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 dot. But right away, I should, alarm bells should be going off because log base 2 of -8 is not defined. It is undefined. So -5 is not a good solution. We need to reject it. Okay, if you did, if you used 4 and you plugged 4 in, we would be just fine. We just need to make sure that our solutions do not involve taking the log of 0 or the log of a negative number. Okay, number 20. So first thing I'm going to do is divide by 4. I cannot multiply the 4 and the 5 together. It's an order of operations thing. I would have to evaluate the exponent first, and I cannot evaluate an exponent if there's an x up there. So we have 5 to the 2x equals 6. Unlike when we did number 16, I believe it was, where we could get a common base, I cannot get a common base with 5 and 6. So I'm going to take the log of both sides. I'm going to do log base 10. I'm doing log base 10 because my calculator knows base 10. You could also pick the natural log if you want to. Okay, but I'm taking log of both sides. Then by our properties of logarithms, that 2x that you see, it can be brought down in front. So we're going to have 2x log 5 equals log of 6. Okay, we're almost done with the exact answer here. We need to isolate our x. Okay, so we need to get that x all by itself. And to do that, we divide. We're going to divide by 2 as well as log of 5. So I'm going to divide by 2 log 5 on both sides. Okay, so our exact answer is x equals log of 6 over 2 log of 5. Okay, so this is known as the exact answer. To find an approximation, so I'll use a little wavy equal sign, which means approximately equal to. I'm going to type this into my calculator. Once again, I know it's a graphing calculator, but I'm not going to use any function that you wouldn't have on your scientific calculator. So I'm going to do, I have a log button, so log of 6, close my parentheses, divided by. Now that 2 log of 5 needs to go in parentheses, or some of you have a fraction button on your calculator, which would be fine as well. But if you don't put the 2 log of 5 in parentheses, it's going to divide by 2, but then multiply times the log of 5, which is not what we want. So the correct approximation is 0.56. 0.56. Another way to enter it into your calculator, if you find this easier, is to do log of 6 divided by 2 divided by log of 5. So that would be another way where you don't have to put the denominator in parentheses, but you have to divide twice by 2 and log of 5. All right, number 21 is similar. So first thing I'm going to do is take the log of both sides. I'm going to pick base 10. Again, I cannot use the same method I used for number 16 because I can't get a common base with 3 and 5. Then I'm going to move those exponents down and make them coefficients. It's one of our properties of logarithms. because they are binomials, I'm putting them in parentheses. Now I'm going to distribute, and as I distribute, these numbers inside the parentheses, they're going to stay coefficients. They're going to stay in front, okay? I don't actually multiply them by the 3 or the 5. So I'm going to have 2x log of 3 minus 5 log of 3 equals x log of 5 plus 1 log of 5, or just log of 5. Since I'm trying to solve for x, I see an x here and I see an x here. If I'm going to isolate the x, I'm going to have to get the terms that contain an x on the same side of the equation. I'm also going to have to get the terms that do not contain an x on the same side of the equation. So to do this, I'm going to subtract this x log of 5 from both sides. And I'm also going to add 5 log of 3 to both sides. So on the left, I have 2x log of 3 minus x log of 5. And this equals log of 5 plus 5 log of 3. Because that cancels and that cancels. Now I'm going to factor out my x. And last step is to divide. So I'm going to divide both sides by what I have in parentheses there on the left-hand side. So x equals the right-hand side of the equation divided by what I see there in parentheses on the left. So this is known as our exact answer. You do not have to simplify any further. Okay. Sometimes we would use our laws to, I guess, make it look a little nicer, but we're not requiring that. To get our approximate answer, let me type this into my calculator. So in the numerator, which I'm going to put in parentheses because both our numerator and our denominator have 2 terms. So numerator log of 5 plus 5 log of 3. And then I'm going to close my parentheses twice actually. So closing once for the 3 and then closing a second time because that's the end of the numerator. Then divided by parentheses 2 log of 3, close parentheses, minus log of 5, close parentheses twice. So we get, it's about 12.08. All right, got just 2 more. So number 22 says we need to determine how long it would take for a sum of money to triple if it is invested at a rate of 8% per year compounded quarterly. Okay, this time because I see compounded quarterly, this is the other formula, the other compound interest formula. So it doesn't give us a principal, You can make up your own if you want. Like maybe I would say P is equal to 100. I don't know, just make something up. If P is 100, A is 300 because we're trying to triple our money. It doesn't matter what you pick for P because our answer is going to be the same since A is always going to be triple what P is. Okay, so feel free to pick whatever you'd like for P and then just make A 3 times that. Our interest rate is 8%, but I'm going to enter it in as a decimal, 0.08. Compounded quarterly means 4 times a year. That n we see in the denominator also appears up in the exponent. And then t is what we are looking for. That's what we're solving for. The first thing you're going to want to do is just to divide both sides by 100. By order of operations, I cannot multiply the 100 times what's in parentheses because I have to evaluate the exponent first, and I cannot evaluate that exponent. So I'm going to divide both sides by 100, and I get a 3 over here. So this is what I was saying. It doesn't matter what you pick for P. As long as you make A 3 times that, you're going to get a 3 over here on the left no matter what. Let me take 1 plus 0.08 divided by 4. And I get 1.02. Now my calculator knows order of operations, so it is dividing first and then adding the 1. As long as you have a decent scientific calculator, it's going to know order of operations. But if you have like an old scientific calculator, then you'll have to know to divide first. All right, now this is actually really just kind of like some of the ones we just got done doing. I'm going to take the log of both sides. So log of 3 equals log of 1.02 to the 4t. Remember that you could also take the natural log. In fact, you know what? Let me just show you. You can take, oops, didn't mean to delete that 3. Maybe I'll do natural log here because you could pick either log base 10 or the natural log, which is a base of e. Maybe I'll show you natural log. So we're going to get the same answer either way. The properties of logs still applies, which means I can take that 4t down in front and make it a coefficient. And then to finish and to solve for t, I'm going to divide both sides by 4, as well as the natural log of 1.02. Okay, because then on the right-hand side there, I would just have t, and that's it. So t equals, we're supposed to round to 2 decimal places, it says. Maybe I'll use my approximately equal to, it doesn't matter. So t is approximately equal to, since we're rounding to 2 decimal places. So I've got natural log of 3, close my parentheses, divided by, I need that denominator in parentheses, or I could also divide twice. So maybe I'll do divided by 4 divided by the natural log of 1.02. So 13.87 years. All right, last problem here. And then you're fully prepared for the final exam, right? So this one, we're given this formula, A of t equals 75 times the quantity 0.8 to the t power. And we want to calculate the half-life. This A of t, it's not A times t, it's like an f of x. So it's only one variable. And over here, I'm going to put 37.5. Now, why 37.5? Well, because it said the initial dose was 75 milligrams, and I'm trying to calculate the half-life. Half of 75 is 37.5. Okay, all I got to do is now solve this. I'm going to divide both sides by 75. And I'm going to get 0.5 over here, which shouldn't be surprising since I'm calculating a half-life. Okay, then I'm going to take log of both sides. You can pick log base 10 or the natural log. It is totally up to you. Okay, I guess I'll go back to log base 10. It really does not matter. And then by our laws of logarithms, we can take that t and move it in front, make it a coefficient. And then the last thing I need to do is to divide both sides by the log of 0.8. That is what will isolate my t. So t equals, we'll say approximately again, approximately equals. So I'm going to do log 0.5 divided by log 0.8. And my half-life is approximately 3.11, and it's hours based on what it said in the problem, is that our time was in hours. Before I sign off, let me just show you that if I change this to natural log, so if I do natural log 0.5 divided by natural log 0.8, I just want to show you we get the exact same answer. So it really doesn't matter which one you use. All right, guys, I hope you rock this final exam. Thanks for watching.